right, welcome back to section 10.2. The next thing we're going to do is a lot of exponent rules review. So all of this should be review. If you need further instruction on exponent rules, that is in chapter 4, sections 4.1 and 4.2 if you want to look at those a little bit further. But we're just going to say R and S, we're going to have them be rational numbers because we're dealing with rational exponents. And A and B should be real numbers, okay? So if you have a to the r times a to the s, so basically same base, and we're multiplying them together, you add the exponents. That would be a to the r plus s. We talked about the negative exponent. A to the negative r is 1 over a to the r. If you are dividing a to the r over a to the s, so same base, and you're dividing, you subtract your exponents, a to the r minus s. If you have a fraction and it's raised to that negative power, you're basically going to flip everything around because a is not happy where it is. It doesn't want to be in the numerator. It wants to be in the denominator. B is not happy where it is either, so it switches to the numerator, and that gives them a positive exponent. Let's see, a to the r raised to the s. This is if you have an exponent raised to an exponent, you multiply those exponents together. Let's see, if you have more than one thing in a parenthesis, they are multiplied together. This is not about adding or subtracting within a parenthesis, so these are things that are multiplied together, and they are raised to an exponent. You can distribute that to each one. So that would be a to the r times b to the r. If you have a division, and again, there's no adding, there's no subtracting going on, it's just a over b, and it's raised to the r power, you can distribute that. That'll be a to the r over b to the r. And the last one is that anything to the 0 power is 1. So take a screenshot of that if you need it. There's lots of exponent rules that you are welcome to use. So let's do another example. In example 3, we get to use some exponent rules. We're going to simplify, and we're going to write with only positive exponents, okay? And we're going to assume that all variables represent positive real numbers, so we're not worried about imaginary solutions, okay? The first one in part A is 3 to the 1/2 power times 3 to the 1/3 power. So we've got the same base and they're multiplied together. So with our exponent rules, we know that that means that I should be adding my exponents, okay? So that'll be 3 to the 1/2 plus 1/3. So we're going to add our exponents together. And yes, that involves adding fractions. So if you're adding fractions, you do need a least common denominator. With 2 and 3, our least common denominator would be 6. To go from 1/2 to being out of 6, I'm just going to multiply the numerator and denominator by 3. So 1/2 is equivalent to 3/6. For 1/3, to get a denominator of 6, I'll just multiply the numerator and denominator by 2. So 1/3 is equivalent to 2/6. Okay, they're the same value, just written in a different way. Now that they have the same denominator, we can actually add our fractions together. 3 plus 2 is 5, so 3/6 plus 2/6 is 5/6. So now we've combined that all as much as we can. It has a positive exponent, and we are done. Okay, B is a little more interesting. We've got a to the 3rd, b to the -4, over a to the -2nd, b to the 1/5 power, and everything is getting raised to the -1/2 power. So from here, there's different ways that you can do this. So one option is that we could distribute the -1/2 to everything. The other option is that we could simplify what's inside first and then raise it to the -1/2 power. Personally, I think it's a little easier to simplify what's inside the parentheses first, because this is going to give us a lot of fractions. And we only have one fraction so far, and this is going to give us more. Okay? So that's probably what I would do, is simplify inside first. So with the a's, so these ones have the same base. You're dividing, which means I'm going to subtract my exponents. So 3 minus -2 is what I'm doing over here. So I'm doing 3 minus -2. Minus a negative is really plus a positive, so 3 plus 2 would give me a to the 5th. With my b's, I'm also going to subtract my exponent. So I'm going to have -4 minus 1/5. Okay? When I'm doing this, I do need a least common denominator because I have a fraction. So I need to convert my -4 to how many fifths that would be. So imagine you have 4 whole pieces and we're dividing each pizza into 5 fifths. So we would have 20 slices, wouldn't we? Because 5 over 5, or multiplying by 5 and multiplying by 5 give us 20 over 5. It is negative, and then we are subtracting 1/5, okay? So negative 20 over 5 minus 1 over 5 would give me negative 21 over 5, okay? So that's just dealing with that quotient rule with dividing when you have the same base, okay? Now that I've simplified as much as I can on the inside, then I'll multiply, or I'll raise it to the -1/2 power. So I can distribute that to both terms in here. I guess they're all part of the same term here, but both exponents. So what I'm doing is I'm doing 5 times -1/2. So that'll be -5/2 for my A. With B, -21 over 5 times -1/2. Well, negative times a negative will give you a positive. 21 times 1 is 21, and 5 times 2 is 10. So it'd be 21/10. All right, now that I've got it to here, I do need to simplify it just a little bit more because I need to write it with positive exponents. So B has a positive exponent, so it is happy being in the numerator. So B to the 21/10. The A has a negative exponent, so it'll go in the denominator, so that'll be A to the 5/2. And that is the simplified form of part B. Now it's your all's turn. You get to try one and show me how much you've learned.